So you don't need me to work it, or you do need me to work it? Yeah. Okay, 15 is where we will start. -3, x minus 1, x plus 4. We're obviously in intercept form here, yes? How do you know? 2 parentheses, and if it has 2 parentheses, then it's giving me how many points? 2, and the only form that gives me 2 points is intercept form. What are the intercepts here? +1 and -4. Tell me what you know before a graph should be happening with this graph. It's going down because of the negative in front. Is it skinny or wide? Skinny, because 3 is bigger than 1. What's the y-intercept? We don't know. We don't know. Yeah. Oh, that probably is confusing. You want me to do mine by 3 then? All right, x equals 1, x equals -4. If we're going by 3s, so +1 and -4. I'm assuming that means that's why y'all got such a big value for your vertex. Let's find the vertex though. How do I do that? Okay, that's standard form. We're intercept form. Add them and divide by 2, right? So 1 plus, oh, I see why y'all didn't like this. -1.5 or -3/2, which happens here. Yes, no, maybe so. All right, now we just plug it in and roll with it. If you remember how to do that STO on your calculator that I showed you yesterday, this is one that I would definitely use STO for. But if you don't, that's okay. We can still plug it in. Y equals -3 times. I'll use the decimal. I know y'all like decimals a little better. -1.5 plus 4. I get -3 times -1.5 minus 1 is -2.5. -1.5 plus 4 is +2.5. And I don't know what that is. Somebody with a calculator. 18.75. 3, 6, 9, 12, 15, 18 on the dot. 18.75 right there. Yes. 18.75. What else on your homework? Y'all like these, didn't you? Better? No? Everyone but 15. Way better than standard weeks. You're really not going to like today, but I'm sorry. -2 x minus 3 squared minus 3. Tell me what you know before you graph it. Sad, it's going down. It's what? It's not, but compared to average, it's a little bit skinnier than the average one, right? Not a whole lot, but because it's a 2, it's still pretty close to 1. What's the vertex? 3, -3. So 1, 2, 3, 1, 2, 3. There's my vertex, also my axis of symmetry. Now I need an easy point. What'd you pick? X equals 4. Plug it in, plug it in. All right, -2 times 4 minus 3 squared minus 3. I got -5. So that point is 4, -5, 4. Let's see, I'm down to 3, so come on. 3, 4, 5. Reflect and connect. Anything else? I try to do that before I leave each day for the next day, so it's already set up. Yeah, there is. Oh no, sorry. It's kind of one of those things they assume that you know from Algebra 1, but nobody ever does, so I reteach it just because I want to make sure you understand. All right. Again, I'm not going to spend a real long time on domain and range because most of you know domain and range. It's the notation of the domain and range that's going to be brand new to you that I'll spend more time than anything else on. So let me take just a second to review domain and range in its most basic form first. Tell me what, oh, like just wait before I, okay. Today is the 8th. You ready? Tell me what domain does, or tell me what domain is. It's all the x values. It's everything that x can be. It describes the x of a graph or a function or an equation or anything like that. It tells you what all x can be, or it tells you what x could not be. Okay, which means that range describes what? The y values. So if I look at just, and I guess I'll say this here. Um, X values, if you're looking on a graph, we're talking about left to right. If I'm talking about Y values, then I'm talking about up and down. Okay. So if I looked at a basic parabola, and I'm gonna put this one here like this. How would you describe the domain of this graph? In other words, what all could X be? Infinite. There's no restrictions on X, right? It could be anything in the whole wide world. Does everybody agree? So maybe I say X is all real numbers, or maybe I say, I don't know how your previous teacher taught you to describe domain and range. I'm going to teach you a new way today. But for whichever way you did it, X could be anything in the whole wide world, right? Does everybody understand why? As you look at that graph from left to right, there's never any place, even if I come all the way over here, it might be way, way up, but there's still a corresponding value that goes with that X, right? Is everybody okay with that? How about though, so this is domain, how about the range though, because it's a little bit different. If range describes y's, and y is that vertical axis, what do you think the domain of this parabola, the range of this parabola here? All real numbers greater than negative whatever that value is, right? If that's -1 and that's -2, then it would be all numbers bigger than -2. Could it equal -2? Yeah, there's a point there, right? So maybe I say y is greater than or equal to -2. Would you understand why I said it that way? Okay. We're going to take this concept and we're going to write it a different way. We're not going to use these inequalities anymore. That's baby stuff. I'm going to teach you interval notation. So this is the new stuff. Y'all ready? Okay. No? It's almost so sad, Leah. No. Tell me when you got it. You ready? Y'all are so funny. Everybody's got all these different little colored pens and stuff, and y'all are color coding. And all right, let's just look at that first inequality. That y is greater than or equal to -2. And let's think about what this looks like on a number line first, because I think that'll help you make the connection between the two. I'm going to call this interval notation. Sorry. This is inequality notation. This is an inequality, but I'm going to show you how to go from inequality to interval. This was just like the heading that I should have put on here, and I didn't. What did I put at the beginning? I'm going to show you how. This is what you already know. I'm showing you how to make it into interval notation. Y'all are so funny because y'all always want it to be just, this is whatever you need it to say in your notes. I won't take your notes up or anything. All right, if I think about this on a number line, here's -2. Tell me what I do. Dot arrow. What kind of dot? Like that? A filled in. Why is it filled in? It includes. So in fact, I'm going to come over here and say anytime I have that line under here, ooh, bless you, that's a closed in dot, as opposed to this being an open dot, right? And then we set an arrow. Which way does the arrow go? Why is it to the right? Greater than. Which way do the numbers get greater than? Well, to the right, because this goes up this way to the right, right? Now, if I told you that it goes on forever and ever and ever, give me a mathematical way we can describe forever and ever and ever. Infinity, right? Infinity. Do you know what an infinity sign looks like? It's like a sideways 8. I'm going to call this end infinity. What do you think then that I would call this end? Negative infinity. Okay? Now, in interval notation, we don't use the inequality sign or the dots anymore. Instead, we're going to use brackets and parentheses. And here's what we're going to do. If there's a line under or the dot is filled in, we're going to use a bracket one way or the other to indicate it includes that value. If the dot is open, or there's no, it'll make more sense whenever we start doing it, I promise. If there's no line under it and it's an open dot, we're going to use a parenthesis, and that's going to clue me in that it includes it or it doesn't include it. So if you see a bracket, it includes. If you see a parenthesis, it does not include. Okay? Have you done it before? Oh, good. Okay. So here's what we do. We use a combination of these brackets and parentheses, and we will write an interval, hence interval notation. So what we'll do is we'll start with the smallest value that x or y could be, and we'll go up to the biggest that it can be with a comma in between, okay? And it could be, you remember it now? It could be any combination of brackets and parentheses, depending on what you include and what you don't. And I will tell you this, infinities, plus or minus infinity, always gets a parenthesis, okay, on whatever end it's on. I'll give you just a second to catch up, and then we'll go write this one in interval notation and see what happens here. Yeah, it's like a little asterisk, like note to self. Plus or minus infinity always gets a parenthesis. You think you understand? See if you can write y is greater than or equal to -2 in interval notation then. Yeah. If you think you got it, see if you can write this in interval notation. I haven't really shown you yet, but some of you have seen it before. right. Good job. Look at you. So you have done it before. Oh, good. All right. So what's the smallest that y can be? Because I start with my smallest. -2. Is it a bracket or a parenthesis? A bracket because it includes it. And then it goes up to what? Infinity. Infinities always get parentheses. There it is. Yay. See, I'm glad I did this today then because I didn't know. Good for Miss Lopez. Wow. Y'all are the first group. Yeah. How would you say all real numbers?
Oh, you do like it's like an R, but you just put an extra.
In interval notation. In interval notation, parentheses, brackets, whatever. How do you say anything at all? What's the smallest it could be? You go small to big. What's the smallest it could be? If it could be anything on this number line at all, what's the smallest it could be? Yes. That's how you say all real numbers. Yes, that's how you say all real numbers if you want to say yes. But if you want it in interval notation, this is how you do it. All real numbers. I was saying if it was a number line and it could be this, that's interval notation for all real numbers. You probably did it. I teach it that way whenever I say X is all real numbers. Is that how she did it? Okay. Negative infinity to infinity is anything. So if there's no restrictions and it can be anything in the whole wide world, we say negative infinity to infinity. Okay? Let's see. Wait on this one. It's okay, Harris. We'll wait on you. Good. Let's say I've got this really kind of crazy graph here. And I want to describe the domain and the range of this crazy little graph right here. And this one I've cut off so that you can really get the feel of how domain and range works. Oh my goodness. What? Sorry. It goes to sleep. No. Like, so when I do domain and interval notation, I'll do a D and then a colon. Yeah, for your notes, I probably would. So looking left to right here, what do you think the domain is? What's the smallest x can be? -2. We all agree? Would it include -2 or not? Yeah, why? It's bubbled in, right? So that tells me I need a what? A bracket. And then it goes up to 1, right? I'm looking at x right now, right? So left to right. Domain is always left to right. So it goes to 1. Does it include 1? Yep. You try the range on this one. Don't say it out loud if you get it.
that, so it includes one because it's passing through.
It includes one because there's a point right here. Remember, domain is left to right. So I start the furthest left the graph goes is here. And then I have graph until I get to this point right here because that's where it stops.
I'm brain with you right now. I forgot to eat breakfast.
So now why I always tell students to bottoms up on your range. Go from the lowest up to the highest, bottoms up. So it's the same, like if you, before this, you would say that x was between -2 and 1. This is just doing the same thing. It's taking those same numbers. It's just a more concise way to write it. Does that make more sense? Okay. Yeah. Bottoms up. From the bottom up. Always smallest. Most of the time it will, but you'll have some times when it'll have. And infinities always. If this were open instead of closed, then it would be a parenthesis. Like, if it was like this, it would be a parenthesis. If it were open.
So all of these are closed.
All of these are closed. Was open. That will not happen very often. Yes. Yes. Yes.
Everything is correct.
How about the range?
-1, so bracket -1.
From the bottom up. So go to the very lowest point on the graph. What's the y value at the very lowest point? This point is 1, -1, right? So the y value at the very lowest point on the graph is -1. And now go up, bottoms up. So from that lowest point, go up as high as it goes. And it stops right here. What's that y value where it stops? 2. So now let's apply this to our parabolas, because for every one you graph from now on, you will include the domain and range and interval notation. Yay! Yeah, you gotta get used to it. Everything we graph, you'll do domain and range on. In fact, not just these, but especially these. All right. What's nice about parabolas is the domain is the same on every single parabola always. What is the domain? All real numbers. How do I say that? Negative infinity. Every quadratic, and listen carefully because here's yes, every quadratic has a domain of negative infinity to infinity. Every quadratic has a domain of negative infinity to infinity. Because you could keep going to the right as far as you can, and there'll always be a piece of graph. That's right. Infinities are always infinities, because can you actually be infinity? No. So you do a parenthesis, because you can't, that's really a conceptual thing, right? It's really just telling me I'm getting super duper big or I'm getting super duper small. Really right. Okay, now the range. What? You want a dance party? Go ahead, we'll watch. You dance, I'll sing. What's the range? What's the smallest y could be? Somebody said it. 3. Is it a bracket or a parenthesis? 2. Infinity. It's a parenthesis. Just to tell you that was the vertex. Let's do another. Describe the domain and range. Try it on your own and then we'll do it together. You should definitely never miss the domain on these. Right? Even if you don't understand range, you should never miss the domain. They're always the same. What are they? I did that on purpose. Negative infinity to... I really didn't. How about the range? This. There you go. Why? Because negative infinity, it's going downwards, so the smallest it can be is negative infinity. Then it goes up to -2 with a bracket. Your vertex is always going to tell you your range, and it's always the y part of your vertex. You just have to decide, is it negative infinity up to the vertex, or is it the vertex up to infinity? Yes, no, maybe so.